ప్రతి ఒక్కరికి నమస్కారం. Today our 21st session of Nirman, learning to the tinkering. సో ఈ సెషన్ లో మనం ఆర్డినో మరియు దానికి సంబంధించినటువంటి కోడింగ్ డిఫరెంట్ కాంపోనెంట్స్ ఉన్నాయి. వాటి యొక్క కోడింగ్స్ ఏ విధంగా మనం ఆర్డినో ఉపయోగించుకుని చేయాలి, ఎలా చేస్తామనేది ఇప్పుడు ఈ సెషన్ లో మనం నేర్చుకుందాం. సో ఇవాళ ఈ కార్యక్రమాన్ని మనకి సమర్పిస్తున్న వారు గవర్నమెంట్ ఆఫ్ ఆంధ్రప్రదేశ్, డిపార్ట్మెంట్ ఆఫ్ స్కూల్ ఎడ్యుకేషన్, సమగ్ర శిక్ష, SCRT, UNICEF మరియు విజ్ఞాన్ ఆశ్రమ్. So my colleague Vipul will explain the sensors and their Arduino coding 1. Today is the topic. So see carefully and learn it. Thank you. Over to you, Vipul.
Thank you, Raju. So good evening, everyone. So today is the 21st session of the Nirman, Learning Through Tinkering. In this today's session, we are going to learn about sensors and their coding. So before starting to the session, there is one reminder regarding ATL marathon competition. So last date for the submitting your entries is the 10th of April. So try to submit your entries before that. So don't wait till the 10th of April. Just try to submit your ideas on before the 8th or 9th of April. So what will happen? On the last date of the submitting ideas, there will be lot many people at the same time trying to access the site. At that point of time, there will be possibility that site might get hacked. Or if you want to participate and you want to submit your entries and you're trying to submit on the 10th April, at that time you might have found some difficulties while uploading your videos or something like that. So just be careful with that and just try to submit your ideas before the 8th or 9th April. So it will be better to have proper time. Okay. So let's get started with the session. So before starting, what this session we are going to cover is, so we are going to cover the Arduino coding, right? So for that, there are some prior knowledge has to be needed. So in the last session, we have learned about Arduino pins, some of the input-output devices, and now we are going to see the coding of some that sensors, and we'll see what the C language is this, and what are the some operators and terminologies used in the C while doing the code that we are going to see, and some of the Arduino sensor coding that we are going to learn. Okay. So in the last session, we have learned about the input and output devices. Okay. So what are the input and output devices? So as you can see on this slide, there are lot many components are present. On the left side, you can able to see lot many sensors were there. Color sensor, gas sensor, PIR sensor, all are the sensors were here. And here are some output devices like LED, motors, buzzer, and relay drivers. Okay. So these are the output devices and these are the input devices. But how we are classifying that and how we are dividing that, whether it's an input device or output devices. So see the definition I have written. Input and output devices also called as IO devices. It's kind of hardware component that can human operate and can interface with the controller. So these are the all devices we can interface with our Arduino. Okay. So inside again we have to divide that. So these are the input sensor. What the sensors are doing? That sensor is observing our current environment. That is observing some change. That is observing some events. And these are kind of information that sensor can able to take from the environment, right? So this information that sensor is transmitting to the Arduino. So what our Arduino is doing? Arduino is listening to that particular sensor's information. So Arduino is acting as an input. So sensor is acting as an input. So that's why all the sensors are the input devices. And what are the output devices? Arduino is telling them when to operate. So now we are telling Arduino to LED. Now you have to turn on. When you have to turn off. That Arduino is telling that, right? So that information Arduino is sending out to the devices is called as output. And these are the output devices because Arduino is telling them to when to turn on and turn off. The information is sending out to the Arduino. That's why these are the output devices and these are the input devices. So why it's necessary that why to learn whether it's input device or output devices? So while we are doing coding, we have to first explain that, tell that coding whether this device is in input or output. That is the first step. So that's why we have to know that get to know that whether these devices are input or output. Okay. So what are the digital pins? That's we have already covered on this last session. What are the digital inputs and digital outputs? Okay. So let's see. So suppose I'm typing here Arduino. I'm opening Tinkercad. Now I'm just typing Arduino. Okay. So as we can see, there are from 0 to 13, there are 14 digital input output pins. Digital pins are there, and there are total 6 analog pins. What does it mean? So we can connect digital kind of pins or sensor, digital kind of devices we can able to connect on the sensor. Okay. And on the analog pins, we can able to connect analog kind of devices. So what are the digital and analog devices? So let's see first what is the digital input and digital output. Okay. So digital input pins sense the presence and absence of voltage on the particular pin. Okay. Firstly, we need to tell Arduino that which pin we are using to reading the input. Therefore, we are using pin mode, pin comma input to configure the pin. Okay. So let's see the example of digital input first. Okay. So I'm deleting this Arduino. I'm checking the example called button. Okay. So button is one kind of input devices. Why? Because it's physically checking whether its button is pressed or not. We are manually going to press that button, and Arduino is sensing that environmental changes, physical changes they are sensing. No, so that's why it's input devices. Okay, and we have connected that sensor to pin number 2. See, there is button. We have connected 5-volt supply. We have connected ground to pin via one resistor. So if we don't keep our resistor, what will happen? Ground will go here directly, and this pin is already internally connected. So if we start the simulation, ground and 5-volt, if we press the button, ground and 5-volt will become short, and this will might damage our Arduino. That's why we are keeping one resistor. If you don't keep it, then directly ground will go, and it's always detecting 0 volt all the time. But we want to detect 0 and 5-volt. There will be two possible states will be there in the digital signal, either high or low. So if we run the code, if we go on the code, I'm selecting text mode. So if you see, I'm expanding this. So whatever the parts is there in the slash, this is the commented part that is not going to execute inside the code. That is used for just explaining, elaborating the code part. So what is that code is there? What are the pins we are using? That is one kind of information there that we are using. So see. So pin number 2 is an input device. Why input device? Because button is an input device. We have to define where we have connected pin number 2, and this is the input devices. That's why we have explained pin mode 2 comma input. Similarly, pin mode LED built-in comma output. What is this? This is an inbuilt LED. Inbuilt LED is connected on pin number 13. That is an output devices. LED is an output devices, right? So we have explained that first. These are the devices. Which devices we are using? Two devices we are using. One is the switch and another is an LED. Okay. So we have explained that whether it's input and output device. That is the first step of coding. What is the next step? Now, what we have to do in this code? We have to sense this pin, whether its button is pressed or not pressed, right? So what we are checking? Digital read. Digital read is one kind of command that is reading what voltage is coming on this pin. That is one command for that. Digital read and pin number 2. So it's detecting whether voltage is coming on this pin or not. Okay. And what is doing is storing in this button state. Okay. So if button is not pressed, 0 volt is going. So what will happen? Button state is equal to 0. And inside the if condition, button state is equal to 0. 0 is equal to high or not? It's checking whether it's high or not. 0 is equal to high. High means 1. 0 is equal to 1. It's not 1. No. So it's wrong. This statement is false. That's why it's not going to execute this part. It will execute the else part. So what is else part? LED built-in is low. That means LED should not glow. So when we are pressing this button, high logic will go. So if high logic will go, this LED will turn on. Okay, it will go inside this loop and it will turn on this LED. Okay, so this is how this code is work. First is the setup part. We have to define the pins, and in the while loop means this part is continuously getting executed. This one time is getting executed, and this while loop is continuously get executed. Okay, all the time is after 10 seconds, 10 milliseconds, it's checking all the time whether it's button press or not, press or not, press or not. Okay. If we start simulation, if you click on the button, okay, that see this LED is getting blinked, right? This is how this digital simple read example is there. So where is using the read? Digital read. Here is the digital read is one command to reading the digital input. And similarly, first of all, in the setup function, we have to write pin mode and input device. If that device is input, if it's the device is output, then we have to type pin mode and which pin you are using and output if the output device is there. And to read that particular pin, we have to use digital read command. And why to use digital write? To explain them whether its device has to be turned on or off. See carefully. If we are reading the state of the button, we are using digital read. And when we are telling the LED to turn on off, we are writing digital write. Okay. So that is the difference of digital input and output. Okay. So this is button is one kind of simple sensor, right? So can we use another kind of sensors? We can use the digital kind of sensor in the same way as we have using the switch, right? So let's go ahead. And similarly, there will be analog pins is also there. So there are total 6 analog pins are there in the Arduino. What they are reading? They are reading some analog values. Analog values means what? That is continuously changing all the time. Okay. So how the digital sensor work? It has only two definite states, right? High or low. In the analog sensor, there are some limits. From 0 to 5 volt, there will be 0 to 1023 steps will be there. So we can get 1, 2, 3, 4, 2.5 volts we can able to get in the analog voltage. And for that, we are using analog read command. Okay. So this is the thing are there. So first of all, when we are getting any sensor, we have to get to know that whether this sensor is an output device or an input device. That is very straightforward because every sensor is an input device. First thing is clear. Now what second thing we have to see whether that sensor is digital sensor or an analog sensor, because their button kind of sensor is also there, which has only two logics, high or low. And there will be some kind of sensor which has some analog values, which means it has some states that has some continuous value from 0 to 5 volt that continuously getting varied. So first we have to distinguish which sensor is analog, which sensor is digital. For that, we'll see. Last time we have studied about this table, right? We have learned about different kind of sensors and actuators. Inside that, we have already learned about lot many sensors. There will be 20 to 28 sensors are there. We have learned about this sensor. So what is this sensor? Just we have to define that whether it's analog sensor or digital sensor. Just we have to say like that. Okay. First, it is potentiometer. Whether it's analog sensor or digital sensor, it is simple. It is analog sensor. Why? Because it's not giving only two values like 0 and 5 volts. It's giving the range of values, right? If you connect ground over here, 5 volt over here, if you rotate this knob, we can able to get values from 0 to 5 volt, right? So it's an analog values, and that values are changing according to the how much knob we are rotating. So there is one analog sensor. Okay. Now just see how we can use this sensor. We just have to use analog read function for that. So let's see on this code. Now I am deleting this. Now I am deleting this Arduino. I'm deleting the example of switch. Okay. Now I'm just taking the example of the analog digital read. Okay. So see, I'm connected my potentiometer to A0 and connected 5 volt and ground. If I start simulation and if I open my serial monitor, I can able to see the 0 value. If I rotate, the value get varied and it will come up to 0 to 5 volt. If 0 is coming, 0 will show. If the 5 volt is coming, then 1023 will display. This is one analog sensor is how it works. Now see, what are the different kind of sensors? LDR is one sensor. Whether it's input, whether it's digital sensor or analog sensor, it is also giving some values from 0 to 203. This is one kind of analog sensor. Why? Because its values are getting changed according with the light fall on this object, right? resistance of this sensor will get varied, right? So it is one kind of register based sensor. Okay. Second thing, one is kind of force sensor, whether it's analog or digital, that is also analog sensor. Why? Because it's detecting the pressure, how much force is getting applied on this sensor, and this force can be changed, right? For 4 kg to 50 kg, it may differs. The force is measured in Newton. That force can vary. That is why this is one kind of analog sensor. Flex sensor. Flex sensor is analog sensor, and that is also one resistive based analog sensor. How we can check? So see, I'm deleting this and just taking flex sensor. Right. I'm taking one flex sensor, one force sensor, and one light dependent sensor, light dependent resistor, right? LDR photoresistor. So by depending the environment values, the resistor value of this particular device will may vary, right? So we just simply check. We'll take multimeter 1, 2, and 3. There are 3 multimeters. I'm checking with a resistor. Okay, resistor. So if I connect one leg to this and another leg is to this, similarly I'll connect all the sensors. I'm just checking whether its resistor is changing or not. Resistor will vary according to that. Okay. So this kind of sensors are called as analog sensor. Why? Because this value is getting changed because of the environment. I'm checking the resistor. That's why I'm keeping here resistor. There are also voltage to resistor. If I start simulating, see, every sensor has some different resistor value. If I'm building this sensor, resistor value is getting changed. See the multimeter, resistor value is changing. Force. If I'm applying more force on this, the resistor value is decreasing, right? Similarly, if the light is falling on this object, is varying, resistor value is changing. So how we can connect? As we have seen, the Arduino potentiometer code is there, right? A0, same code is there. Same code will be applicable for all these kind of resistive based sensors. How we can check? I'm just simply deleting this. I'm taking one Arduino. I just simply connect 5-volt supply to one of the end of this. I'm taking one resistor. So I'm connecting ground pin to this and one more pin to this. And where we are detecting A0, that's we have to measure over here. Okay. So if I start the simulation, I have to open the serial monitor. See, the value is varying. It's coming 33. And if I turning this resistor, then value of this is getting varied. So if I change the resistor value of this, the value will get little bit different than 33 and 7. Okay. So if I have increased the register value and I am opening the serial monitor, 256 is showing, right? So if I'm bending this, values get differentiated. So where we can use it, how we can use it. Now these are the sensor values coming. Now how the code is working, let's see, take a look fastly. Pin mode, A0. This sensor we have connected on the A0 pin, right? And this sensor is an input devices. And where it's connected, A0. That's why pin mode A0, input, because this device is an input. Serial monitor. When we want to use the serial monitor, we have to define the serial begin this command. This function we have to use. This is predefined function. Everyone has to use that. We want to use serial monitor. These steps has to be there. Okay. So why we are using whatever the sensor value we are getting, we are able to displaying on the serial monitor, right? That's why we are using this monitor. That's why we have to begin this monitor first. And this 9600 is the baud rate. Baud rate means how much speed that we are able to receive this data. That is the speed. We can increase the speed 115,200. There will be some defined baud rates will be there that we can keep. But by default, we are using 96000 baud rate. So what? This is the one step activity. Only one time we have to execute this. Now, second thing, what is this? This is the void loop. What we are reading, the sensor value. This is one kind of variable where we are storing our value. Now we are reading the analog read. we are reading the sensor value on these pins, right? Analog means what? Varying values. From 0 to 5 volt, there will be some varying voltage will be there that we are observing, right? So that's why we are using analog read A0. A0 means what? This is the pin number. And we are storing that sensor value in the sensor value variable. Whatever the value will come, we are going to store in the sensor value. And now what we are doing? Serial print sensor value. And there is no double quotation over here, right? So what I'll do, I'll just copy, press enter, and I'll print over here again. And I'm putting inside this double quote. Okay. I'm typing sensor value is. Okay. Now what will display? This sensor value will able to display as it is, and value will be coming as a 193. So when you put any value in the double quotation, it will act as a comment. And if you remove the comments, it will take the variable. So whatever the value stored inside this, you can able to get it over here. So see how it's working. Now I am doing the start simulation. What will happen? Now see, sensor value is 256. Sensor value is 256. Why it's coming? And if I changing, value is changing, but sensor value is continuously displaying. So this is one kind of comment. If you put inside the double quotation, it will act as a one comment. And if you remove that comments, it will take the variables, whatever is there. Okay. So it's showing the value. But how to get use of these values? How we can use this value? Now see, observe the values carefully. I'm just putting inside this comment. So as I explained, if you double slash these things, it will go inside the comment. This statement will not going to come inside the code. If you do the start simulation, this part will not come inside this code now. Okay. Now see the value carefully. If the 0-degree rotation is there, 256 will become. If I have tilted it, the minimum value is coming like 59. So we can use this kind of value. Okay. So what we can do? If condition, if sensor value is greater than 100, then what we can do? We can just simply turn on one kind of motor. For turning on one kind of motor, what we'll do? Digital write. For that, what we have to define? Pin number, right? Pin number. Suppose we are using pin number 8 and we have to make it higher and semicolon. And if we open this curly bracket for the if condition, we have to close it again. Okay. And for that, we are using another output device. No. So for that, we have to explain it that here also in mode input this kind of pin. Sorry. Okay. Enter. Okay. And this is one pin number 8. And this is motor is one kind of output device. No. Because our Arduino telling that when to turn on and when to turn off, right? Output. So if we run on this thing, first we have to connect one motor on this, right? So what we can do, we just have to take one motor. See motor, just simply take and see it has one positive lead and negative lead. We just take positive, positive, negative to negative. Okay. If we start simulation, sorry, it seems like some errors are there. What are the errors? Word setup. So it's saying output. Spelling mistake is there. So what is that spelling mistake? Here is some spelling mistake is there, right? So output. So again start simulation. The error will be gone. Okay. Now motor is revolving. Why is motor is revolving? Because see, analog values are getting more than 256. We have to also put some statement. If the value is lesser than 100, then only turn on this motor. Okay. So currently, what will happen? Value is coming 256. It's not less than 100, right? If the value is coming less than 100, then whatever there is inside this curly bracket, this part will get executed. What is inside this? 8. Pin number 8 is high. What is connected on the pin number 8? Motor is connected, right? Now, if I'm rotating this flex sensor and value is going below 100, then see, observe this motor is get revolving. Such a kind of like that, you can able to use this flex sensor. Similar like that, whatever the analog kind sensor which is based on the resistor, like that I have explained you, like this force sensor, LDR sensor, flex sensor, potentiometer, you can use in such a way like that. Okay. This is one simple basic program. If the value of the sensor is falling down below certain values, they can turn on some motors, turn on some buzzer, and turn on some LEDs. You can do such a kind of programming with that. Just take a quick review. What is that inside the program? Void setup. This executes one time only, right? So there are two devices. One is the input sensor, and which is connected on pin number A0, and there is one output device which is connected on pin number 8. Output device is motor, and input device is flex sensor. And what we are deciding, what we are doing, we are storing some analog values, reading some analog sensor values on the A0 pin and storing in the sensor value. And what we are doing, we are just printing this value on the serial print. And we are checking if this value is going below 100, then turn on some particular motor. That is the simple thing. And see some digital write. This is one function. Analog read. This is one function. Serial begin. This is one function. Pin mode. This is one function. That is fixed syntax is there that we have to remember. For every different controller, there will be some different syntaxes will be there. Okay. So see, force sensor is analog sensor. Flex sensor is analog sensor because its values are varying. Airflow sensor. What is this sensor? See, how much water is flowing through this pipe depends on that. The value of this sensor is get varied. Values get varied. It's not giving only high or low, right? So that means it's not a digital sensor. It is an analog sensor. Okay. If water is going fastly, that this rotor will move more fastly. Then again, the voltage on these pins will get more fastly, right? So due to that, we are able to read that readings, and which is working on the Hall effect sensor. Hall effect sensor means what? If the rotor is moving fastly, the pulses, magnetic pulses will be generated, and that is generated in the form of voltage. And that's voltage our Arduino can able to read. See, observe this resistor, flex sensor, and LDR and potentiometer. That is giving the information in terms of resistor. Our Arduino will not able to read the resistor value, right? Arduino can able to voltage. That's why we are converting that resistor value into the voltage. How? We are connecting one resistor network. We are giving some voltage. We are dropping some voltage with these two kind of resistor, and we are able to getting the readings in between two resistors. That is kind of voltage divider. Okay. So our Arduino can able to read voltage, not resistor. That's why we are using some signal conditioning to make in the form of voltage. Similarly, airflow sensor, we can directly connect it because it will giving the value in the form of voltage. Similarly, water level sensor. Water level sensor is an analog sensor or digital sensor. It's an analog sensor, right? Because how much depth is inside the water, depending on that, value is getting varied. So if it's depth more, the resistor value will decrease. Similarly, like that, how we are use this sensor, we have to use that sensor here. Water level sensor. Rainwater sensor. Rainwater sensor can be used as a digital sensor and analog sensor. It is basically one kind of analog sensor only, but we are using one kind of model is there along with that sensor, is right? That is converting that analog value into digital values. So we can use both way, analog and digital way. If the digital sensor is there, it is very straightforward. You just have to use that button code, right? Just we have to digital read. It is very easy. And soil moisture sensor. This is also same. It's giving the resistor value, and it can give you some analog value and digital value. So basically, it's an analog sensor. If you don't use this blue color module over there, this sensor will act as a analog sensor. Okay. Gas sensor. What it does? It is also one analog sensor. It detecting the gases. It detecting how much amount of gas is there in the environment. It is measuring the 0 to 1000 ppm. Gases are measured in the amount of ppm, parts per million. That is unit of detecting the gas sensors. Okay. So now there is some another kind of sensor will be there. Biometric sensor. We don't know whether it's an analog sensor and digital sensor. In this case, what we can approach this sensor, how we can do the coding of this sensor. What we have to do is just you have to go on some browser. You have to type that sensor. We have to open one tab and type that is BMP 180 sensor, and you have to type 180 Arduino. How I am able to see that BMP 180? So see, on that sensor only there is name BMP 180. So you just have to type PMP 180 and just see the different kind of articles will be there. You have to open and read these articles. They will give you some amount of information. Whenever you are approaching any new kind of sensor, just try to read the sensor in the depth, how that sensor is working, whether it's an analog sensor and digital sensor, at what voltage it is operating. That things we have to explain, see. So they have explained you how to use this kind of sensor. They have explained you what kind of extra components that you need. One Arduino you need, one sensor you need, some kind of jumper wires you need. Okay, so how to connect that sensor, that they are also explained. Now see, remember that they have some explain you, some notes will be there. Remember that this sensor is working on 3.3 volt. If you connect 5 volt on this device, your sensor will get damaged. So if you didn't read this article and if you directly connect this PMP sensor to 5 volt with the Arduino, this sensor will get damaged. And afterwards, if you started doing coding, at that time you will not able to know that whether the sensor is get damaged or not. You will blame on the code. This code is not working or sensor is get damaged. Why is get damaged? Because you have connected 5 volt. Because if you're operating on 3.3 volt supply, then you have to connect 3.3 volt, not 5 volt. But how you can able to get to know whether it's working on 5 volt or 3.3 volt? You have to read that documentation part. Okay. So if you know that, now you'll able to know that this sensor is working on 3.3 volt. Now how to use, there are some things they have explained, and the code they have explained it here. Okay, so these are the very complex code. Okay, so we are not able to type this code accordingly. For that, what we have to do, we have just simply have to go on the internet and see which library they are suggesting. This is one kind of library that we have to include. If you want to do this code, you just have to include this library in your Arduino. How we can use it? How we can include this library? Just go on this Arduino software. If you go on this Arduino software, what you have to go? You have to go on the sketch, go on the include library, and you have to go at the manage library. If the new sensor is coming, this is how we are going to approach. Okay. This display will open, library manager will be open. So after that, what we have to do, we have to type the name of that particular sensor over here, PMP 180. I have typed here PMP 180. So some libraries will coming over here. So this is the library, PMP 180 is there. No? So it's already installed because I have already used this library. Okay. So this, okay, this is library. This is how we have to install the library. Now where you can see, we have to go on the file examples, and what we have to search for that name where this library is. See PMP 180 sensor. So we just go on that tab and click on this. So we can able to get that code as it is, and you can just directly upload this code. Okay, this is how it's work. So see inside that code, there is the library. What does that mean? There is a lot many bigger code is already they have made. Whoever is made this sensor, they have already typed the bigger codes is there, and they have included in this library. And you have given in this only small example codes will be there, but there will be lot many bigger codes will be there inside this library. That kind of codes we are not able to type, and this is very hard to get. And if you want to see what is that inside this code, what you can do, just you have to go on your PCB, your folder, and you have to go on the documentation part. There will be some Arduino folder, and there will be library folder is also there. Inside that, whatever library you have installed, that can be opened. So see PMP 180, I have installed this library now, right? So we can able to get the source file. Inside that, whatever that .h is explained, we explain inside this. Okay. So see, there will be lot many difficult kind of codes will be there that we are not able to know. So see, this kind of codes is very complex to get. These are the codes. They have already typed for you. And if you started typing this kind of codes, it will be very difficult for you to type. So what you can do, you just simply use this kind of libraries so that your work will be reduced. Okay. So this is the simple code for that. So similarly, let's jump on to the sensor. Just try to read this article. So currently this code will be very difficult for you guys. Just try to explain, just go through the simple kind of codes. So don't use such kind of devices. And one but first thing, when you will able to show whether we can able to do this analog, whether it's simple analog sensor, digital analog sensor, and when we are going to use the library, right? That is one question. So this is the temperature and humidity sensor. This is the DHT11 sensor will be there, right? So what you can do, you just go on the site, just type DHT11 Arduino. Okay. If you type that, some articles will come. First, if you have any new sensor, just try to go in the depth of that sensor. Okay. Just find out some best article that you can suit. Just try to read. So see, they have also doing the code and which library they have suggesting some libraries to install. If they are suggesting some libraries, just install that library. So DHT11 library you have to install. So similarly, they will explain you have to go on the sketch and include this library. Okay. And there will be or already ready-made code will be there. Okay. This is how we can use it. So these are the different temperature and humidity sensors will be there, right? This is not giving some normal analog values from 0 to 0, 0.55. There will be some data like temperature, actually 22 degrees Celsius, 56 degrees Celsius humidity will be there. This needs some calibrations. That calibration is done by the whoever is going to manufacture these sensors, right? So they have already mapped that sensor value to this temperature. If 0 value is coming, that 0 degrees Celsius I have to display. That calibration, that calculation, and difficult code they have already implemented. That we can use. We cannot directly connect this sensor directly to the analog pins and try to read these values. We have to use the libraries inside that. So there will be some different calibrations will be there. For that, we have to use this kind of libraries. In the industry also, they are using some kind of libraries to work this sensor, right? So you have to go on the net and search for the different kind of sensor, how they are using, at what voltage they are operating, and try to use the different kind of libraries. If the no library is required, you can directly take this sensor. Microphone sensor is also there. There we require some library. Some buzzer is there. There is some simple output device. There we don't need of any libraries will be there. If you have simple LED code will work for this buzzer module code is also there. Ultrasonic sensor. There is also one library will be available for that. You just have to go on the site, just type on the ultrasonic sensor, and there will be some libraries will be mentioned. You have to include the library. And how to include library, I have just already explained it. Okay. How to include the library? You just have to go include library, this sensor. If get opened, will take little time to open, and here you have to type ultrasonic sensor. Okay, then automatically that examples will come to you, and just afterwards you can go in the depth how that code is working. So in the next session we'll try to cover that how that sensor is going to operate, because it will be very difficult to cover all the sensors and coding in the one session. So this is one IR sensor, whether it's giving some digital information or analog information. So this sensor is giving the digital information. If some obstacle is coming in between that, it's just giving high or low, right? It's not giving the how much object is far and away. It's not giving the more information of that particular sensor. It's just giving you high and low. So this is one kind of digital sensor. Just you have to provide 5-volt supply, ground supply, and there will be output pin. That is, we are going to use it at a switch, same as a switch. We are using pin number 2 for the switch. You can just directly go and connect on that pin, and just you can use the simple digital button code for that. So this is how this sensor can be worked. Similarly, pulse sensor will also be giving you some analog values. Okay, and similarly, PIR sensor. PIR sensor is going to give you some two definite values, either high or low. Okay, pulse sensor C is giving some amount of information. Some person has different amount of pulses, right? So it's getting some different ranges of pulses. That is why this is analog sensor. PIR sensor. What PIR sensor is doing? It's just giving information whether movement is detected or not. how we can use it? We'll just go on the Tinkercad. Now I am just deleting all these things. Okay, I'm just giving you the example of some digital sensor. I have explained you the analog sensor. Now I'll just giving the example of digital sensor. Okay, how we can use it, how to do the coding of that. Just simply type the Arduino over here and see the button example. Okay, button example. Now I have to use the PIR sensor. Now I am removing the extra part and just I am typing PIR sensor. Now I am taking this PIR sensor. Now see what are the pins have? Signal, power, ground. Let's connect power pin to 5 volt, ground pin to ground pin, and we can able to get directly voltage on this particular pin. So we can what? We can able to connect. We can directly able to connect it on this pin number 2. And if we do the start simulation, now if the range is detected, observe this LED. If I am continuously moving, this LED is continuously blinking because we have set the code in such a way like that. Okay. How its code is working? Go in the text. This is the commented part, and it's observing the pin number 2. What is pin number 2? It is digital input of this PIR sensor. We are connected on the 2. This is the input device. As I told you, sensor is an input device, and we are directly connecting to the pin number 2. So it's just observing the voltage, whether it's coming on that. So how we can be so sure? Just take one multimeter, and see now whether it's detecting voltage or not. So just positive to positive and ground to ground. Okay, it's one ground thing. Now we just have to see the ground is coming or 5 volt is coming on. Now currently 0 volt is coming. Okay, I'm just taking here 0 volt is coming. Right. If the PIR sensor there is any movement is detected, then 5 volt is coming. The pin number 2 is just detecting the voltage on that. If the voltage is getting detected, we are turning on this LED. Okay. Yeah. So this is how one simple analog and digital sensor will work. There is one tricolor LED. This is on analog sensor. Just you have to go on the site and check whether how the individual sensor is working. If the LCD laser module is there, just go in little bit depth, whether it's digital sensor or analog sensor, and how to operate this, and whether we are able to need any kind of library to operate this sensor. If the library is needed, then just go and install that library. The capacitive sensor. This is also one kind of sensor. The capacitance of this sensor will get varied. How much is the button? If our pressing our finger on this sensor, the capacitance value will change. The capacitance value is going to change. Voltage value also going to change. So we can directly use it as a normal analog sensor, right? So relay module. This is one kind of digital output device. It will work same as of our LED. The LED code for this sensor will use for the relay sensor. Okay. So motor drivers ICs will be there. They are needed some kind of library to operate this kind of sensor. Okay. So just try to understand just basic things. There will be, if some random sensor is coming, you just have to identify whether it's an analog sensor, whether it's digital sensor. If it is analog sensor, then whether it's a simple analog sensor, whether you can use it for the potentiometer code for that. If it's not, if it's getting difficult, then you have to type that particular sensor name on the site, and they will recommend you some kind of libraries. They have recommended some kind of libraries, just have to install that kind of libraries. Okay. And if you want to go in more depth of that, just you have to go on your file library where that library is stored. You have to go on that, and they have explained you what is inside that header file. Header file means what? Okay. So header files means that what? So this is the header file. At the start, they have explained you #include header files. Include means what? Whatever they explain you the code and type you the code, you have to include in your code. That is there. So we'll try to cover this difficult part in the next session, because we are, the main purpose of that our today's session is we have to identify what kind of sensors is that and how we can able to tackle how to do the coding. Okay. So on the next thing, we will try to see how to do this kind of complex sensor coding. Okay. So that is from my side. So that is not many things that we have to cover, but this time restrictions are there. So that's why we have to see. Now I'll going to explain you these things. What is the if condition? What are the for conditions on the next upcoming session? That will be useful in your coding. Okay. So that is from my side. So yeah. So that is the thing. So just try to explore the things. Just take one sensor and try to search whether how much operating voltage is that, and go on the site and just try to learn that sensor first of all in the depth. Whenever you are using any kind of sensor, just get the deep knowledge on that particular sensor. Then only you can use it on your project. Just don't go into simply take the sensor, just do copy paste the code and just implement the things. Try to go on the depth, how that sensor is working, what is the output operating voltage of that particular sensor, and how that code is working. Then only you can proceed for that implementation. Okay. Okay. So that is from my side. So yeah. So thank you. So yeah, thank you for everyone to attending this session, and thank you for giving this valuable opportunity to present that session in front of you. So thank you for our technical support those who are giving. Thank you for Government of Andhra Pradesh, Department of School Education, Samagra Shiksha, UNICEF, and thank you for Vigyan Ashram to make that things possible in front of you. So yeah, so that is from our side. If you have any query regarding this session or any project related queries, then you can reach us and you can simply write the mail on the attending atlandhra@gmail.com for that. Yeah, thank you. That's from my side. And please do like and subscribe for our channel. If you liking our content, just subscribe our channel. So after that, you can able to see our video contents and all these things for the upcoming session. So yeah, thank you from my side. Thank you. Hello. Hello, sir. Ismail, sir, are you there? Hello.